Welcome, ladies and gentlemen. So what I'd like to do is kind of go over exactly what is factoring. Now, to really explain or understand factoring, I think you really need to understand what is multiplication. And so basically what I'm going to do is I'm going to go through a couple of examples to kind of explain multiplication, so therefore we can understand exactly what is factoring. Now, the basic idea of multiplication is when we're looking into finding an area. And for instance, let's pretend I have a box here, and this box has the dimensions of 3 by 4. Now, when you were first learning area and learning like multiplication, one of the ways that we determine to find our product is we would make this, well, if that represents 3, then there's 3 rows, and then 4, we're going to have 4 columns here, right? And then you could add up all the boxes to determine the area. But hopefully through our experience here, that we understand that to find the area, we can multiply 3 times 4, which is going to give us 12, right? Now we start getting into a little bit more difficult problems once we start dealing with some variables. For instance, what if I had x times 4? And well, if I want to find the area, we're just going to have to multiply, right? It's not going to be as as evident as 12, but 4 times x is going to leave us with 4x, right? So the area of that box is going to be 4x. And then lastly, what if I have 3 and I have x plus 4? Now, to determine the area, you got to multiply them. Now, one thing that we can do is I can also break this up into 2 separate boxes. So I can find the area of this box and the area of this box. And remember, if you take the area of both those boxes and combine them, then you're going to have the area of the larger box. So it's much easier, I think, when multiplying area is to separate your terms. So 3 times x is 3x, and 3 times 4 is 12, obviously positive 12. So you can see that the area of this box is going to be 3x plus 12, right? And what you also notice is basically what I'm doing is applying distributive property again, okay? So that's multiplying. When we multiply, we're given the area. Now, I'm going to use this information to now help us understand factoring. So when we're looking at factoring, basically what we're doing now is I'm going to give you an area, and I want you to determine what the side lengths are going to be. So rather than me giving you the side length saying, hey, what's the area, I'm going to say, hey, here's the area. Now tell me what the side lengths are. What are the two sides that multiply to give you the area? Because that's what factoring is. Factoring is rewriting an expression as a product. Right now, my expression is 6. But what 2 numbers multiply to give you 6? Well, your 2 answers could be 2 times 3 or 6 times 1, right? So if I want to rewrite the expression 6 as a product, I could rewrite it as 2 times 3. Or 6 times 1. Both of those are ways for me to factor the expression 6. All right. However, we're not really going to be factoring numbers so much. We want to be concerned about factoring polynomials. So I'm going to go through kind of 2 different examples of how can we factor polynomials to really explain factoring. So let's do 5x plus 15 and 7x squared minus 21x. Okay, so now we got a little bit different story, right? Now we have two kind of boxes, very similar to this one over here, actually. And what I'm going to do is I'm going to break them apart. Now, you don't have to, all right? But again, what I'm trying to do is I am trying to identify what is a side length of my rectangle that I can multiply to give me 5x. Well, obviously, you could have 5 and you could have x, right? So I could say, oh, I'm sorry, well, hold on. I could say 5 and for x. But the problem is if you just say 5x, well then 5x times what gives you 15? So the thing is, x is not shared across these both terms. So the width of the height of this box can only be 5. Because now can you multiply 5 to give you 5x? Yes. Can you multiply a number times 5 to give you 15? Yes. So what are those numbers? Well, 5 times 5x is x, or 5 times x is 5x, and 5 times 3 equals 15. So now you guys can see that I can rewrite the expression 5x plus 15 as the product of 5 times x plus 3. Basically what I did was I found a term, 5, that divides into both of my terms, right? This is number 5. I can find another number that can multiply to give me 5x plus 15. And basically what I did is I divided both of these terms by 5 to get x plus 13. Over here, again, I want to be able to determine numbers that divide into it. And so we know that 7 divides into both of those terms, but also does x. Well, to find my other term, what I talked about that division, to find what's the other side length, just like when you had this. Look at, if I had 6, right? To find 3, basically what you do is take 6, divide it by 2, and guess what? You get 3. So I'm going to take 7x squared and divide it by 7x. Take negative 21x and divide it by 7x. And when I do that, I'm left with x minus 3. So to factor this, I have 7x times x minus 3. So again, just to kind of round out, ladies and gentlemen, the basic idea of factoring is to rewrite an expression as a product. And basically that expression that you are going to be given is the area of a rectangle. And so what we're going to do when we're factoring is we're going to be trying to find out the lengths of the box, because the lengths of the box that multiply to give you that product, or the lengths of the box, are going to be multiplied to give you the area. And therefore, that's what we're looking for, is what is the product that is the same, as the expression that represents the area. And that, ladies and gentlemen, is factoring. Thanks.